Hey everybody, welcome back. Jesse here for Three Prong Gaming. And in today's episode, we are going to start moving our AI around. We're going to do some tasks and decorators and start getting our behavior tree set up. So by the end of this, we'll actually have our NPC go to the building that we place. Nothing too magical, but it's where we need to start. So sit back, relax, and let's get this thing going. Alright, well in the last episode, if you guys missed it, in the last build episode anyways, we set up a few things that we need for this, like the entrances and collision boxes and things like that. Of course, we don't need the collision box for the AI, at least right at this point, but the entrance we definitely do need, so if you haven't seen that, go ahead and check that out. And I want to start this off by kind of prefacing that the way I'm going to do this with my AI tutorials, and it's really how I've tried to do it with all my tutorials up to this point, is I'm not going to just show you the code that I have. I want to show you guys a process. I think that's the only real way to learn. So if I wanted you just to copy what I have, well then what's the point of doing these videos, right? I just let you download my project and you can copy it to your heart's content. But I want to teach you guys how to do this, and I don't think there's enough of that going on, especially with the AI. I've tried looking up a lot of it, and while you can learn some stuff from them and they explain it a little bit, they don't really take you through the process of actually building your AI system. And it can get confusing. AI is a very confusing thing. There's very few people in the world who truly understand the concept of AI. And, it's a small handful. So, and I don't really understand it. I want you guys to know that, I'm sure that somebody's going to watch this and be like, hey, you're doing this wrong. You should do that. And that's fine. Hey, I've rewritten my AI up to this point like 4, maybe 5 times. And all of it worked except for the very first time. The first time I had issues and I had to restructure it. But the last 3 or 4 times I wrote it, they all worked. They were different ways of doing it, but they all achieved the goal that I want. But I felt with each time I built it, it just wasn't quite the way you were supposed to write the code. And I think I've got it to a point now to where it's what is expected. It's the conventional way of doing your AI, but it's still probably not 100% accurate, but it works. I get no errors. And so, yeah, I'm going to teach you guys what I know, but it's probably not the best way to do it. And if it's not, and you know something that I don't, please let me know. And I'm always trying to evolve as a programmer and just as a student in general. So with that, let's get started. And the reason why I say that is because a chunk of the code we're going to write today is actually going to end up not being our final code, but I'm going to show you guys the process. Like I said, I could just show you exactly everything I did. And if you want to know just what I did to make it work and show you my code exactly, then, let me know. A majority rules, right? If that's what you guys really want. But if you actually want to learn the process of how you should build it and how your code should evolve as you move forward, then go ahead and stick with what I'm doing here. All right. So that's it. That's almost 4 minutes worth of me babbling. So let's get this going. This probably is going to take a full episode here. So I'm going to try to bite all this off in small chunks, and if we can achieve something. But today we should be able to achieve our AI running to a building. So first, let's just go ahead and grab our Mpc BP and our Mpc Ai Controller, and let's just drag it into our AI folder just to keep things organized. So move it here. All right, so let's go ahead and go into here. Now we're going to need our behavior tree and our Mpc Ai Controller. I've already got them open up here. So we're going to build some other things in here. We're going to build some tasks and decorators. Now, I loaded this up, and even though in the last episode it showed that it was defaulted to the Mpc BB, it wasn't for me when I loaded it up today. So just go ahead and select that and make sure you have that selected. So we don't need to open our Blackboard, because once we link it here, we can switch back and forth between our behavior tree and Blackboard and only have one tab open. So that's nice. Okay, and then our Mpc Ai, we'll come back to that in just a little bit. So with your behavior tree, you're going to come in, you're going to have this root node right here. This, you can't get rid of this. This is the main thing. All right, so you can only have, oh man, I don't know how deep I really should explain this, because I don't want to assume total lack of knowledge in this, but you know, I don't want to skip anything either. So your root is the main thing. This is the main tick of everything. You can only have one node string coming off of your root. All right, and you can't put any decorators on it. You can't put any services on it. All you can do is link up to it. So what we need to do is we need to come off of here, and you've got composite nodes: selectors, sequence, and simple parallel. All right. Real quick, a selector means that. Oh, let's see. Let's go ahead and pop a selector down here. This is what we're going to need to start off, anyways. Is all the branches that you have come off of here. Think of it as a tree, because you're going to have branches coming off everywhere. A selector means that, say you have 5 different tasks coming off of the selector. A selector means as soon as something succeeds, it stops execution of everything else in that branch, and it comes up here and hits the selector. And if you've got another branch coming off of this selector, it's going to run the code in that. Whereas in a sequence, if you've got the same 5 tasks coming off of a sequence, it's going to run and do every single one in there until one of them fails. Then it's going to come back up, and it's going to, once it fails, it'll come back up to the root of that sequence. And if it's got another branch, it'll shoot off that branch. Now, if you don't have a second branch on either a selector or a sequence, ultimately what you're doing is it will jump back up to the main selector or sequence of its branch and start the sequence over again. Okay, so we're going to start off with the selector here. Hopefully you guys kind of understand that a little bit. You'll understand it as we move forward a little bit more. I'm just going to name this node working. We're going to have several branches coming off here, and this is actually not going to be our top branch. If you guys saw my AI teaser, you're going to see that there's a lot of stuff going on here, and this is ultimately going to be the working branch. Okay, so anytime our AI is in working mode, this is the branch they're going to run. So with that, what we need to do now is we need to come off of here, off of the working. Let's just go ahead and drop in a sequence. Okay, and the sequence, let's just go ahead and name this construction, because this is going to be the construction workers branch of the working. All right, so go ahead and do that. And with your behavior tree, one thing to note is you can't, unlike your normal node system, you can't drag backwards. So you can't create a graph cycle. You can't drag backwards off of your nodes. You can only drag from top down. And the way it's laid out, and I'll explain this as we do our next couple branches off of this construction bit, but everything's going to run left to right. All right, that's how it is. So it's important that if, well, I'll show you. Let's just go ahead and build our first. Let's go ahead and build our first task. We're going to do. There is a wait, a default wait task. Let me show you guys this real quick. Wait. We've got this wait here, and you can set seconds in here, right? But that's pretty. When you've got 10 AI and you've got them all waiting 2 seconds, it still makes them look the same. All right. So we want some deviation in this. So we're going to create our own custom wait function here. So when you create your base task, just like with any of them, you get a really kind of crappy name. This is one thing I, as well as a lot of people, don't really like is unlike a normal blueprint, when you create a blueprint where you can automatically change a name right away, this one you can't. So every time you place it, or every time you create one, it automatically creates the task or decorator or service in the same folder as your behavior tree. So eventually we're going to end up having to move all this because we're going to have a ton in here. But go back there. I'm going to rename this one. I'm going to start it off with a T because it's a task, underscore wait random. Okay. And I'm doing this is because, like I said, we're going to have a ton in here, and all these little icons look the same, whether it's a service decorator or task. So if you've got it starting off with a T or a D or an S, you're going to have them all pretty much side by side alphabetically, so it's going to be a little easier to find and get to. Okay, so now we rename that. Let's go ahead and go into the function. So any task, what you need here is you need to execute. Just type execute and you're going to get event, receive, execute. Now you got two choices here, receive, execute AI and receive, execute plain. All right. Always choose the AI. It's the more advanced one. You can use one. You can even actually use both, but the system will pick which one's more relevant to what you're trying to achieve. But the AI, what the AI does, and I'll just show you here, receive, execute right there. See, this just gives you an actor, just a base actor. But here, this gives you the controller and the pawn. Now, they're not our custom controller and it's not our custom pawn, so you can cast those. But it gives you more access to them, and it just makes it a whole lot easier. So let's just go ahead and stick with, in everything I do, I stick with receive, execute AI. Okay, so with our random weight, all we need to do with this one is, and we don't need to cast anything off of this because we don't really need it. So we really could use the other one if we really wanted to, but just to stay in the habit of using this one, this is what I'm doing. So let's do a random float in range. Okay. Now you could probably set a variable here if you want, but this code is not going to be long. So if you need to come back and change it, it's going to be just as easy to change that random float as it will be a variable. All right. So just go ahead and put in a delay. All right, now what we need to do is we need to pick a minimum value. So we'll do 0.2. Now remember, this is going to be your delay. All right, so I just set mine for now for a maximum of 3 seconds. Now remember, these are actual seconds. So it's going to pick a float value in between these, and it's going to become its delay. So that way it gives a little bit random feature. Now remember, you don't want to make this value too high. A 3 on normal speed, like a number 3 speed in the game, that's really going to be could be like 15 minutes, right? So it could be a chunk of time that actually passes by before they move. But I figure, some people are lazy. They may not want to move right away, so it just gives them some random deviation, and it doesn't allow them all to move at once. So if you drop 4 AI in the world right away, they're not all going to immediately move at the same time. So okay, we always want to try to create as randomized stuff as possible. Then at the end of every receive execute, what we need to do is we need to do finish. Now we don't have a finish execute AI. It doesn't matter. All we've got is a finish execute, and that is perfect. So since we really have no code going on in here, we always want this to succeed, right? It's just a random weight. There's no real code going on. So we'll set success, all right? And that will be important. We can go ahead and close this out. Go back to our behavior tree, and I'm just going to move this around. So every time I close one, I'll go back to my behavior tree. So why that's important to succeed is because we're running it off of a branch. Let's do weight. Now there's our random weight right there. And I should have probably renamed that. Let's open this back up. You can set default names for your nodes, so when you drop them in, they automatically have a name to it instead of this generic BT task blueprint base. So we'll do this one, weight random, and then we compile and save it. Come back into here, and it didn't change right away, but you can see right here it's set it. So just select it and then press enter, and it will set the node name for us here. So now we know it's random weight, and below it tells you what the actual name of the task is. So the reason why we made this succeed was because this is in a sequence. So this will now continue to execute after this is done, after this delay is done, it's going to execute to the next one. If we set it to fail in a sequence node, it would jump up and stop there. Now if it was, this was a selector and this succeeded, then it would jump back up to the top of this. It wouldn't continue to run this execution down here. It would just jump right back up. Okay, now you can always select this. Most nodes, now this is, I'm actually surprised I don't have it here, but there's really no code inside. But there's a lot of times you'll have the option to inverse stuff here. But yeah, it's a little bit off topic right there. So our next one, what we need to do is now we need to assign some work to our MPC. So let's go ahead and create another task, and we will call this one, go back out here. I want to rename this F2. We'll name it T_assign work. And this is for the construction workers. So let's just go ahead and name construction right there. Assign work construction. Okay. Save it. Go back into here, back into that. So we need a receive. Remember, like I said, all your tasks need a receive execute. There's a tick. If you need a tick for a task, then you can use it. But up to this point, I haven't needed that. I used tick. You used your tick in your services. Is mostly where it's used at. So with this assign work construction, first let's just go ahead and set this because I'll forget. Let's do assign work construction, right? We'll just leave it as that. It makes it a little neater. Now what I do with all this, with my casting, is I make it a little easier so we can reuse it. You could probably set a global function for it. That would probably work. But all I've been doing is I'll drag off of here. Let's see. Actually, we need two variables here. Let's call this one controller. Make it of Mpc Ai Controller. Make another one. Let's just call this one pawn. And I'm not following my normal conventions here. That's okay because this is just part of the behavior tree. Let's do Npc BP reference. Okay, they don't need to be editable. So let's go ahead and drag in the controller. Now, sometimes, even though this task may not be running, these variables may be loaded. Now, as I've told you guys before, casting can be very expensive, and AI itself is very expensive. I saw a video recently on Twitch from Ian Sheeden from Epic, and he was saying that if you can write your tasks behavior, your tasks, decorators, and services in C++, you're going to speed everything up tenfold. It's going to be that much faster. That's how much nodes slow down your AI. It's still capable of doing it, but if you got a lot of things like your casting, your spawning inside your AI, your tasks and decorators and stuff, you're really going to slow down. So we need to try to prevent that. So what we do is we drag off of this and we go is valid. So if this is already loaded, we don't want to reload that. We don't want to recast to this. All right. So go ahead and run a branch out of here. Hook this up, hook that up. So if it is not valid, what we need to do is we need to take our controller and we need to go cast to Mpc Ai Controller. Right click it. Let's just go ahead and make this convert to a pure cast. Okay, and then drag in our controller here, set it to that, right? Put the false into that. So if it's not set, that's what we're going to do. Okay, now we need to come off of here and we need to put in another branch, grab our pawn, and we need to do the same thing, get that, and is valid, and then plug that in. And then now both these branches, the true needs to run into there because we need this code to execute no matter what. So drag that into there. All right. And if the pawn is valid or is not valid, then we need to drag off of this. We need to cast to Npc BP. Go ahead and make this a pure cast again. And just to make things a little nicer, let's go ahead and drop in a reroute node. And set your pawn, alt, drag it in, and set it there like so. Okay, I'll come back and clean this up off of camera. And then at the end of this, that's pretty much all we need for that right here. So let's go ahead and select all of this, deselect the beginning string right there, and let's right click it and let's go collapse nodes. All right, we're just going to make that. So we're going to call it reference cast. That's fine. Let's just jump into this really quick. We're 19 minutes into it. Oh, running a little bit longer than I anticipated. So we've got all this now. So let's rename this pin. This first one, we'll rename this one controller. All right, now we need to make it a base AI controller. AI controller. We don't need our Mpc Ai controller because we're not passing the Mpc AI controller. We're just passing a regular AI controller into it. So it's going to disconnect it there. So just go ahead and hook that back up. And then same thing with this one. We need to rename this one, we just need to name this one pawn. And that is fine. It is defaulted to pawn, so we don't need to change that because it'll come through just fine. So in the output, just go ahead and plug both of these into this, and we don't need to call it that. Let's just go then, and it'll remove the name. All right. So that's it. So we've got that. So now what we can do in the future is go ahead and press the back arrow. Is now all I've been doing with this is I've just been copy and pasting this into every task, so I don't have to rewrite that every time, and it's going to make it a much cleaner task to look at whenever you go back in to rewrite your code. Okay, so that's what I've been doing with that. So now with this, what we need to do is we need to go into our Mpc Ai controller quick, open up full blueprint editor. Let's delete this tick. Off this begin play, we need to get a variable here. Let's call this one camera controller reference, and set it to the camera pawn controller reference. All right, and then drag off of here, and we need to, oh, man, sorry about that. Go ahead and right click. We need player controller, get player controller, there it is. And then we need to cast this to the camera pawn controller. Let's go ahead and make this a pure cast as well. Okay, and then set your camera pawn or your camera controller reference right there. There we go, because we're going to need access to a couple things in here from the behavior tree. So go ahead and jump back into the assign work construction. Go ahead and drag in your controller reference. Get it. Now we need to get camera controller reference. From here, we need the construction manager reference. Okay, so now we've got that. So now what we need to do, what we need from the camera manager is we need the list of proxies. We need the buildings that are in there. So go ahead and get proxy right there. And we need to check its length. Go ahead and drag off that, type in length. And is the length greater than 0? Okay, so do we have a building that is being worked on? Okay, so go ahead and drop in a branch here. Move this back a little bit. And then drag it up into there. So do we have a proxy? If we don't, go ahead and drag off the false and type in finish. We've got a finish execute right there. Select that. We want that to be false because it failed. We don't have anything, so we want this node to fail. All right. And then but if we do, what we need to do now is go ahead and we need to go ahead and just drag off this. This is ugly. Like I said, none of this code except for this reference node is really going to be here by its time it's all said and done. But I'm trying to show you guys the logical process of following through this. So let's just go ahead and grab our proxy and get, right? We're just going to stick with get 0, right? We're going to get the first one that's in there, and we're not going to move until something else, until, 0 is different. Which will happen when we do our construction. Once the construction proxy is built and it's destroyed, then this number, the reference, this proxy being passed in here at 0 index will be different. All right, so let's just go ahead and drag off of that. Now we need the entrance. Entrance, where is it? NCE, there it is, get entrance. All right, that's the entrance we made in the last episode. And so what we need to do, we need to set this to a location. So we need to go back into our behavior tree, and we need to select our Blackboard. We need to make a couple new keys here. Let's go new key. We will make it, this is like a variable, but these are the only things you can select from are in here. They're just generic placeholders for you to be able to use. So we're going to select a vector. Let's go ahead and call this one target location. Press enter. It is a vector. Let's create, I'm just going to create these now so I don't have to come back because we're just over 24 minutes. Let's create a new one, an object. An object is pretty much anything. It's any actor. Object is the base of every actor in the world. So it pretty much refers to everything. It's very generic, but we're going to call this one destination. Okay. And create one more object. We will call this one current location. Press enter. So real quick on destination, what I'm going to do so I know I'm I'm not going to necessarily do it for all of them, but I will set, I'll show you guys here, entry description. This destination, this is the destination building that the NPC is moving to, right? So that's what we're using this one for. Current location, and I suggest you doing this because, trust me, it gets a little confusing. This is the current location of the NPC when not moving. Okay, so once they're at an actual location, an actual building, and actually I could probably go like this and go current location, parentheses, building of the because we're going to only pass really a building reference to this. So if he's just out in the middle of the world, this won't be set. This is only when he's actually at a building. Okay, so let's go ahead and set the base class here to building master BP. Okay, same thing with destination. Open up the key type and let it know that its base class is going to be the building master BP. All right, so let's compile, or let's say that there is no compiling in the behavior tree and Blackboard, but we'll save it anyways. Control S and go back into here now. So what we need to do is we need to create a variable, and we will call it target location. What this variable type needs to be, this is a special one. We need to make this a Blackboard key selector. All right, so that's going to let it know that it's part of the Blackboard. Now, to be able to access it in your behavior tree, it has to be editable. If not, it's not going to see it. You're not going to be able to manipulate it, and I'll show you that once we drop the node in, that we need access to that. So it needs to be available. So then we need to create another one and call this one destination. And it's already selected to Blackboard key, so make that editable as well. Compile and save it just to be there. And so from the entrance, we need to get world location. All right, so now this is going to give us the location of where the entrance is of the proxy. So grab your target location, get that, and you're never going to want to set this. When you drag it in, you never want to set it. You'll always want to get it. The way you set these is you drag off of that. Now we go set, and you're going to see this whole list of Blackboard stuff right here. Now we made this target location. This task doesn't know what this is referring to. So we need to tell it what it is. So it is set Blackboard value as vector. Okay, so drag our vector from our entrance right there, plug that in. Off the true, go ahead and plug that in as well. Okay, and that is, let's see, target location is that. So our destination, drag this one in, get it. Same thing with this one. We need to set Blackboard value, but remember this is an object. So select object, drag that in there. And so our destination will be this proxy, or drag it off of this get right here and plug that in. Okay, off the get, not the entrance, the get, because this is the actual building reference right there. So that's what we want to set our destination to. Okay, and then that's it. Go ahead and drag off of this and go finish execute. Now we have succeeded because we reached the end of this branch. Okay, so take a second, just kind of look at that and drag it back here. We've got our camera manager that we got from our AI controller. Get the list of proxies, make sure that we have a building in here. If not, it fails. If we do, then we get that proxy. We get its entrance and its world location. We set that to a Blackboard key called target location, and then we set the proxy that we got at index 0, and we set it to the Blackboard value as object destination, and we succeed. All right, compile, save it. Boy, we're at 28 minutes. I was hoping to get this moving. Let's go ahead now. We are done with this one. Like I said, that's going to end up changing dramatically in the near future. So let's go ahead and drag this out real quick, and we will go assign work construction. All right, and you can see because we named the node in there, it's already there. So now, like I said, you got to pay attention here. See how you got a 0 and a 1 right there? We save it, it still shows 0 and 1. But if I move it over here a little bit, save it, now this shows 1 and 0. So this will actually execute first. So pay attention to that. That's how it knows its order of execution. You can layer them over a little bit, click save. See, it still shows 1 and 0, so it's still over too far. Save it, now it's 0 and 1. So now we're okay because we want this one to run first. All right, so now I'm going to, man, I thought we were going to be able to get a little bit further than this. We are at we're at 30 minutes right now. And you know, I think we're actually going to stop here because I'm looking at the code that I have left, and it's going to take a decent chunk of time to be able to do this. So I think we're going to stop here, except for there's one thing we need to do here. Since we exposed those, I'll explain this real quick. Since we exposed this target location, this destination here, since we made them editable, now we can see them right here. So let me show you real quick. If we make this not visible, compile and save it, you don't see those in here, right? So we go back into here, we make them editable, compile and save it, go back into here. Now we see those. So we've got access to those. Now we need to tell this what this is referring to. Okay, so with this, what are we doing here? There we go. Sorry, that was, I don't understand why that wasn't popping up. Now we've got this default right here, okay? So self-actor, see, we don't want this. It automatically selects the first one. This self-actor, I didn't put this in here. You can delete it and then shut down the editor and open it back up, and it's going to come right back. So it's always going to be there. So it's a self-actor. I think it's a reference to the AI controller. I'm not quite sure, but we need to set our target location. You can name this variable inside this assign work construction. You can name these whatever you want, but try to stay conventional so you don't confuse yourself. There's no reason to confuse yourself, to be honest. So try to keep them the same. So I know target location needs to be target location. Destination needs to be destination. All right. So that way, if you don't set that, you got to try to remember, because there's plenty of times I go, hey, how come my code's not working? And then I go back and look through everything, and I try to look down here to make sure everything's matched up, and inevitably I find something that I didn't set. All right, so make sure that that is set. So I'm sorry. I thought that we were going to have enough time to be able to make our AI move today, but we're not. There, you know, that's just the way it goes. So we're just over 32 minutes into this. And I don't want to make it any longer than this. So the next one, I promise, we're going to get our AI to do some moving. And yeah, I hope you guys enjoyed this. Hope you learned a little something from it. If you did, please do me a favor. Go down, hit that like button. If you're new to the channel, go ahead and subscribe while you're down there liking it. If you got any questions about this, leave me some comments. I really enjoy your guys' feedback. I want to thank everybody for, even Julian, he recently caught me making a mistake on one of my episodes and put it in notation. I appreciate that. I'm not perfect. I'm still relatively new to you know, Unreal Engine 4. And so, yeah, let me know. Anything. I like and enjoy that. So check out one of those other videos that are playing on the screen right now. And until next time, peace.